Question 5.51. For the circuit shown in the figure, R1 equals 6 ohm, R2 equals 6 ohms, R3 equals 2 ohm, R4 equals 4 ohm, and R5 equals 3 ohm, and the potential difference is 12 volt. In the first part of the question, we need to find the equivalent resistance for the circuit. So to find the equivalent resistance, let us first begin with this branch. Here R3 and R4 are connected in series with each other. And we know we can find equivalent resistance for series circuit as, we will write equivalent of these two as R34 equals R3 plus R4. So when you add them, R3 is 2 ohm, R4 is 4 ohm, and we get the equivalent resistance to be equal to 6 ohm. After we find the equivalent resistance for R3 and 4, we will reconstruct the circuit. I keep R1 as it is. Then we have R2, R3 and 4 combined together as 1. Then we have R5, the battery. That's it. Next, I'm going to combine these two branches of the circuit. R2 and R34 are connected in parallel to each other. Since they are connected in parallel, I can write their equivalent resistance R234 to be equal to 1 over R2 plus 1 over R34 raised to negative 1. So 1 over R2 is 6 plus 1 over R34 is also 6 raised to negative 1. That gives me R234, which is the combined resistance for 2, 3 and 4 equal to 3 ohm. Once we find this, we can reconstruct the circuit. We keep again R1 as it is. R2, 3 and 4 combine together to form one resistor. And then we have R5, the battery, and the rest of the circuit. Now my final circuit is a series circuit where all the three resistors now are connected in series. So I can find the equivalent resistance as R equivalent equals R1 plus R234 plus R5. So we solve. R1 is 6, R234 is 3, R5 is also 3. And when you solve this, you get R equivalent to be equal to 12 ohm. So this is part A of the question. Next we solve part B. In part B, they want us to find current through resistor R5. Now R5 is in the final equivalent circuit, which is connected in series. And we know in a series circuit, current through each component of the circuit remains the same. So whatever current comes out of the battery is the same current that flows through R1, R2, 3, 4 and R5. And the current coming out of the battery is the total current of the circuit. So I can find current flowing through resistor 5 to be equal to the total current in the circuit I, which can be found by taking potential difference V over R equivalent. So V in the question is 12 volt over R equivalent, which is 12. So current through resistor 5 is 1 ampere, which is also the total current through the circuit. Next we solve for part C. In part C, they want us to find potential drop across R3. So if I want to find potential drop across R3, I will write that as V3, which will be nothing but current through R3 times its resistance. Now what is the current I3? The value of R3 we know from the question, it is 2 ohm. In order to find potential difference, we need the current I3. Current I3 is the current that is flowing through resistor R3, and it is the same current that flows through R4 because they are connected in series. Now my total current I starts from the battery. It passes through resistor R1 And then here at the junction, it divides into two parts. One that goes through R2, which I will call as I2, and the other one that goes through R3, we will call this as I3. R2 has a value of 6 ohm. The combination of R3 and 4 also has a value of 6 ohm. That means these two branch of the circuit has same resistance. And if they have the same resistance, current through them divide equally. So my current I is divided equally between these two branches. That means the current I3 over here will be half of the total current. So I can find my I3 by taking half of the total current. Total current is 1 ampere. Half of 1 ampere will be 0.5 ampere. So let's substitute this for I3 here. Potential drop across resistor R3 will be I3 times R3. I3 is 0.5. R3 is 2 ohm. And when you solve them, you get potential drop across R3 to be equal to 1 volt.